Hi everyone, welcome to another episode of Chemistry with Harvey. Today we're looking at Metal-Aqua ions. We're going to jump straight into this with the definitions of acids that you now need to know. These are two new definitions, a Lewis acid, which is an electron pair acceptor, and a Lewis base, which is an electron pair donor. You can think of these like the reverse of a Bronsted-Lowry acid, where instead of being positive, it's negative, and instead of being a donor, it's an acceptor. So it's fairly simple there. If we put this new definition of acids and bases into the context of transition metal complexes, then we can see that the ligands are acting as the Lewis base and the metal is acting as a Lewis acid, because the ligands are donating a pair of electrons to the metal in the form of that dative bond. This means that the formation of a metal complex is actually an acid-base reaction or a neutralization reaction. However, the acid-base nature of Metal-Aqua ions can go even further, and they can act as Bronsted-Lowry acids or bases. This is because the central metal cation pulls away the electron density from the oxygen, which in turn pulls away the electron density from the oxygen-hydrogen bond. This makes it very easy for the hydrogen ion to drop off, allowing the metal complex to act as an acid. Once the hydrogen ion has dropped off, the metal complex is now hydrogen deficient and so can accept a hydrogen acting as a base. They are, however, very weak acids and bases. The strength of the acid or base is determined by the charge on the metal cation, as that determines how strongly the metal cation can pull the the electron density away from the oxygen. This allows the hydrogen to drop off more easily. Therefore, the more positive the cation, the stronger the acid. Now we're going to look at the reactions between Metal-Aqua ions and alkalis. The Metal-Aqua ion will donate hydrogens to the base in a non-reversible neutralization reaction. It will donate hydrogens until the metal complex becomes neutral. At this point, the metal complex is no longer soluble in water and will precipitate out as a solid. It's worth noting that the OH- is not replacing the water ligand. It is simply moving a hydrogen from the original water ligand to the OH- to form a new water molecule. Here's the example written out in equation form. As you can see, both sides of the equation are neutral. You only have enough OH- ions to neutralize the metal complex. If we were to use a copper 3+ metal ion instead of a copper 2+, then you would just need an extra OH- ion and one more hydrogen would be donated. Here I've just used M as a substitute for a transition metal. In the first one we're looking at a transition metal with a charge of 2+. These are not acidic enough to decompose carbonate ions, so instead they drop their ligands and form an ionic bond with the carbonate ions. This transition metal carbonate molecule is now insoluble in water and so will precipitate out. However, metal 3+ complexes are acidic enough to decompose carbonate ions. These will undergo a neutralization reaction and form the same product as formed when reacting with a base. It will also form carbon dioxide and water. Again, this product is insoluble and will precipitate out of water. Finally, we're going to look at the amphoteric properties of aluminium 3+ complexes. As you know, amphoteric substances are a substance that can act as both an acid and a base. Think water or ammonium. Specifically, when you neutralize an aluminium 3+ hexaqua ion, you get an amphoteric substance. It's not the hexaqua ion itself that is amphoteric. If you add an acid to the neutralized aluminium 3 hexaqua ion, then you reform the aluminium hexaqua ion. If you add a base, then it displaces the remaining water ligands in the aluminium molecule and forms a new aluminium OH4 complex, which is negatively charged and redissolves in the water. Thank you for watching this episode of Chemistry with Harvey. As usual, the notes will be linked in the description. If you have any questions about other topics in physics, chemistry or maths, please do comment below and I'll try and make a video about them. Don't forget to like and subscribe. I'll see you next time.